All right, so I hope you have had a chance to look at page 114, number 8. It looks like this. So let's look at the answers to this, how we want to say this. It just says, at what points does f appear to be differentiable? So it doesn't ask you to justify this, but let's put in some justifications anyway. All right. Well, what points does f appear to be differentiable? So one thing that is tricky about this is, well, it appears to be differentiable a lot of places, and the real question they should start with is, where is it not differentiable? So you can start with where the function is not differentiable and then answer the question from there. So I would notice, not at where is the function not differentiable. And by the way, we're going to ignore the endpoints. There are sort of some special considerations you can make about the endpoints. That's not going to be a big concern for us. So let's look at points in the interior of the domain. So that would be at -1. So not at x equals -1 because there's a cusp there. Not at x equals 0 because f is not continuous. So you can just make very short justifications like that. Not at x equals 2 because f is not continuous. All right, x equals 2 because f is not continuous. So those are the points where it's not differentiable, but that wasn't the question. The question is, where does it appear to be continuous? So what we're going to say then is that, actually it asks, where is f differentiable? We've identified where f is not differentiable at x equals -1 because the cusp is 0 and 2 because not continuous, all right? So f is differentiable on, so these intervals. So let's go ahead and include -2, so it's technically included, to -1, but we cannot include -1 because that's a non-differentiable point. And then we're going to go -1 to 0, but not including 0 because that's a non-differentiable point. And then from 0 to 2, but not including 2 because that's not a differentiable point. And then 0 to 3, and oops. And we actually can include 3 because this is what we call left differentiable, but again, we won't worry so much about the endpoints. Okay, so answering the question, where is f differentiable, requires you to write 3 separate intervals. Remember, when you do this, you're only talking about x coordinates, okay? These are all x intervals on the x-axis. -2 to -1, we're differentiable all there, but not at -1. -1 to 0, we're differentiable all through there, but not at 0. 0 through 2, we're differentiable in that whole interval, but not at 2. And, oh, this is supposed to be a 2 right there. 2. Yeah, because 2 to 3 were differentiable. Okay? Now, where is f continuous but not differentiable? Okay? Let's not justify these because it'd be well, we'll at least justify the not differentiable part. We kind of did already. So, f is continuous but not differentiable at x equals -1. All right, because there's a cusp. So I don't want to, include and f of -1 equals limit as x approaches -1 of f of x. So let's justify the not differentiable part, but not the continuous part. We are not going to include a 0 in this list because f is not continuous there. So we're going to include the other points. Oh, there are no other points where f is differentiable, continuous but not differentiable. Because the other points, like where is this not differentiable? Not differentiable, we know at -1, 0, and 2. But where is f continuous nevertheless? Only at -1, because the other 2 points f is not continuous. Okay, so the only point where f is continuous but not differentiable is x equals -1, that's our cusp. All right, and then whereas C neither continuous nor differentiable, whereas as soon as you're not continuous, you're automatically not differentiable. So the question really could just be, where is f not continuous? Right, would be the same question with the same answer, because as soon as f is not continuous, it's already not differentiable. Okay, well, where is f not continuous? At x equals 0 and x equals 2. Let's not justify those because they didn't ask us to, and we'd have to write a lot, and who wants to do that? Okay, all right, so that is how we're doing number 8. So here is a homework on this. Your homework is page 114, number 1 through 9 odd, and number 11 through 16 all. All right, will there be more videos today? I don't know. I'm still trying to decide where the breakpoint's going to be. So perhaps this will be it for today, perhaps not. Either way, see you later.